Yes, ma'am.
Yes.
So today we will start welding. So let's start with the joining. So joining is the process used to assemble different parts. So welding will come under joining category. Joining process can be either temporary, that is maybe if you are using some bolts or rivets or something, or it can be permanent if you are doing welding. So joining process is what? To assemble the different parts to join the different parts. That is joining. Then welding is the process of joining together two pieces of metal with or without the application of heat, and with or without the application of pressure, or both, and with or without addition of filler material for formation of metallic bond. So here joining is the vast, and welding comes under the joining. Welding, here your joint will be having atomic bond. That means the bonding which will happen in the welding is at atomic level. So let's see first different joining process. So joining is divided into two parts. That is, first is mechanical bonding and second is atomic bonding. So we will be focusing on atomic bonding part. Then again, atomic bonding is what? Welding. This is called as welding. Then welding is again divided into three categories: solid state, liquid state, solid and liquid state. Then in liquid state, it will again divided into two parts: electric and chemical. And electric divided into three parts: arc welding, induction, and resistance welding. So exam point of view, you should know all types of welding of solid state, liquid state, and solid liquid state. You should know how for which material, which kind of welding we are using, and what is the mechanism for the different welding process. Most of the question, the most common welding process that is being used for metal is arc welding. That we will go deep in, and rest all the weldings we will see what is the mechanism behind. So today I will try to cover almost like with the question arc welding, and then in the next lecture we will finish with the solid state and solid liquid state. So what are the advantages and disadvantages of welding? So welding establishes strong, durable, and permanent joints, and it is a simple process that will result a great finish. So in this technique, either you'll use a filler material, or without filler material also you can join the two different parts. And the filler material, whatever you use, is will be stronger than the base material, because what you are doing here, it will when you are directly solidifying your filler material, it will somewhat give you a quenching kind of effect. So that is why your weld will be stronger most of the time, and it is a easy process and can be performed at any place. It is economical and affordable process. What are the disadvantages? It is hazardous, because you have to take lots of safety and security guidelines before doing the welding. Lots of gases will form during this operation, and it is a difficult task. Like you need a skilled labor. If you are doing a manual welding, then you need some skill. You need practice for the welding. If any of you ever tried welding, that your hand should not shaking during the arc welding and all. So that thing is required in the welding process. Now, now whatever we have seen, the division of the welding process. First is solid states, which is also called as autogenous welding. So in this welding, no filler material is required. That is why it is autogenous welding. And all types of solid phases, when we are doing the joining process at the solid phase, that will come into this category, autogenous, when we are not using any kind of filler material. Then the second category, that is liquid state, is also called as homogeneous. In this, the filler material will be provided. With or without filler material also, you can join. The arc welding, thermit welding are the examples of homogeneous. And in this, base materials will be at liquid state. Then the heterogeneous welding, there the filler material, whatever the filler material we are using, will have different composition from the parent material. Like in the soldering and brazing, when we are doing the joining, that the material that we use, that will be of a different. And suppose you are trying to weld iron and silver, that can be done under the heterogeneous process. So these are the three types of welding process. So suppose in the exam they can ask you which is called what, like which is autogeneous, which is homogeneous, and which is heterogeneous. So these names also you should know for solid, liquid, and liquid solid welding. Then some terminology in the welding that we should know. So according to different types of joint and configuration, these are five types of joint. So suppose if you are joining along the length of this of two surface, then it is called as butt joint. Then if you are joining along the corner, then it is the corner joint. And suppose you are joining at the edges, then it is edge joint. Similar as in the diagram, it is explainable what is T joint and what is lap joint. Then a few terminology that you should know uh, in the diagram. So let's first see about root. Okay, so suppose this is your first material. This is your first, both the material are same. Suppose these are two sheets and we want to join these two sheet along the length. So what is this? This is a butt joint. So this is your first sheet and this is your second sheet, which are made of same material and we want to join. So whatever the shortest distance between these sheet that will be there, that is called as root opening or root gap. So why we provide a root gap? This is the shortest distance. Why we provide? So that the penetration of filler material will be high. So that is why we provide a root gap or root opening. Then second is weld pool. This whole thing called as weld pool. So what is weld pool? Amount of liquid metal between the two surface before the solidification. Before the solidification, it is called as weld pool. So whatever the notes that I will be sharing, these definitions are be there. Just read it after that. Before solidification, whatever the amount of liquid metal between the two surfaces is called as weld pool. Then the weld bead. What is weld bead? Amount of material which is added into the workpiece in the single pass. That is called as weld bead. That is amount of material which is added into the workpiece in a single pass. Then the route we have already seen. Then the reinforcement. So what is reinforcement? This is the reinforcement height. So reinforcement, whatever the amount of material which will be projected from the base material. So suppose this much is your base material, and after that some more amount of material is there which is projected above the material. That is called as this area is called as reinforcement. This material is called as reinforcement. Reinforcement. So this is about the butt joint. Okay. Then suppose we have done fillet weld. Okay, fillet, like we are joining two metals like this. We are joining like this. So suppose this is your weld. This is your weld. So this the tip of this weld in the fillet joint. The tip of this weld is called as toe. This face will called as weld face, and the shortest distance between this will be called as root, and the shortest distance between the root and weld face will be called as throat. So mostly in the question in the 1 mark they can ask you what is a throat in the fillet weld. So it is the shortest distance between root and weld face. These all definitions are written in the notes, so I suggest you to read that after the class. And one more terminology, that is weld deposition rate. Here I will write weld deposition rate. So it is the amount of the material added into the workpiece per unit time. So it will be something like kg per hour or minute or second. So that is your weld deposition rate. Now move on to arc welding. Let's start with the arc welding. This is the most important topic for this whole welding course. So arc welding, you should know about the principle. You should know everything thoroughly about the arc welding, because this is the welding process which is mostly used everywhere. So what is that? Firstly, we have seen arc welding is a liquid state joining process. So what happens in this? Firstly, what happens? One electric arc will be generated by the electrode. Then with that arc, heat will be generated, and with the help of that heat, the base metal will be melted. Okay, now let's see the principle. Okay, so what is in arc welding? What we are trying to do? We will convert our electrical energy into heat energy. So what happens in arc welding? What is the principle that we need to understand? Let me make a circuit. Suppose this is your power supply, AC or maybe DC. Then with one cable, we will connect the electrode. This is your electrode. This is your holder. With another cable of your supply, suppose when we are connecting with the positive terminal, other with the negative terminal, if we are using DC. Other cable, with the help of other cable, we are connecting the workpiece. Okay. Suppose this is your complete circuit. Suppose this is joined together. When it is joined together, current will flow in this whole circuit. Okay, it will start with, from the current will start from the positive and go to the negative. The current will flow. So this is your complete circuit. So what we do in arc welding, we develop a arc. What we do, we develop an arc. So how we do that? So what we do, we need to make a electric circuit first that we have made. And what we will do, suppose there are two ends of conductor. Suppose your electrode is first and your workpiece is second conductor. So what we do, we will make a sufficient gap uh, between electrode and workpiece. Suppose around 5 mm or less than that. So we will make a gap between the electrode and workpiece. Okay, and current is flowing throughout the circuit. So what happened? Due to the flow of current, the air particles which are present in between the electrode and the workpiece, that will become ionized. Okay, so these ionized mean, what is mean ionized? That the particles will start colliding with the high rate of acceleration. Okay, and due to this collision, there will be this will be responsible for the generation of heat. So what this ionized gas is called, that is called as plasma. It's a kind of plasma. So arc will be generated, and because of that heat, it will your workpiece will it will your workpiece will start melting. Okay, and with that we will do joining. Suppose there is a gap between two metals that you want to join. Suppose it is less than 5 mm, so then you will not use any filler material. And if it is greater than 5 mm, then you have to use filler material. Okay, filler material. So what is here? What is happening in arc welding? We are generating one arc. So what are the properties of that arc? Arc will work like a plasma. What is plasma? Plasma is a high energy state of a material, which will give you very high temperature. So temperature in arc welding will be around 5000 degrees Celsius. So with at that high temperature, your workpiece, there will be heat generated on your workpiece. So this is the principal concept of arc welding. Anyone is having doubt till now?
No.
Okay. Now, uh, if we know the principle, there is a difference between arc and spark. Okay, the same way spark also generated, right? So what is the difference between the arc and spark? You have seen, or maybe in your home also, sometimes there will spark will happen and electricity will be gone. Spark is what? That is very instant. It is for instant of time only. An arc will blow continuously. There will be large current in your arc and there will be small current during the spark. Okay, that is your arc, that you should know what is an arc. Now when we are clear with the arc, we'll okay, I'm not able to see the messages. So if you have any doubt, you just say. Otherwise, I need to go and check. Okay, it's not for me. Then, okay,
And
yes,
uh,
yes,
the process happens in case of gas lighter. Is it spark? Is it spark?
gas lighter. Uh, I think so, yes. It is not arc, that I'm sure. So what is happening here? Our electrical energy we are converting into the heat energy. Now what arc length? So whatever the gap between your workpiece and electrode will be there, that is called as arc length. So mostly your arc length, when we do welding, what arc length we give most of the time, that will be your dia of electrode. So there are two type of arc length. One is short arc and second is long arc. So suppose if your arc length is lesser than the dia of electrode, then it will be short arc, and if it is greater than the dia of electrode, then it will be long arc. Now let's move on to the power supply. Whatever the here we just in the principle we have just seen that we used one power supply. So now let's move on to the power supply. So according to the thickness, according to the what material you are going to use, you will decide what kind of power supply you need. So basically power supply, there will be two kind of power supplies that will be present. First is AC, that is alternating current, which will have no polarity, and second will be DC, direct current, which will have two polarity. What is polarity? Polarity will tell you in which direction electrons will flow. So first AC we will see. First let's see the DC. So DC will be divided, DC power supply when you are using in the arc welding. Suppose you are using DC power supply in the arc welding. So there will be two polarities. First is straight polarity and second will be reverse polarity. So what happens in the straight polarity? You will connect your electrode with the negative terminal. So your electrode will be negative and your workpiece will be positive. Okay. So your workpiece will be positive. So what we call in the question, most of maybe they will ask you in terms of DCSP, that is direct current state polarity arc welding, or they can one more name for this, direct current electrode negative welding, or direct current workpiece positive. So what you have to remember for the straight polarity, that your workpiece will be at positive terminal, it will be positive. So uh, so now electron will be moving towards your workpiece. Okay, so now and one more thing you should remember, it will be moving towards the positive. So more heat will be generated at your workpiece. So always one more thing you should remember, either for reverse or for the straight. So if your workpiece or electrodes, whatever will be at positive, 70% of heat will be generated on that, and whoever will be at negative, 30% will be heat generation on that. That is heat generation. So now in the straight polarity, your workpiece will be positive and your electrode will be negative. So 70% of heat will be generated on your workpiece. Okay. So what from here we can decide the application for the straight polarity. So this will be used for the thick sheet. Suppose your workpiece is very thick, so you can use straight polarity to join thick sheets. Okay, what are the applications for straight polarity? It is used in plasma arc welding. That we will see later also. In this class only, we will see what is plasma arc welding. It is also a kind of arc welding where we are using plasma, more plasma, how we will providing. So it's kind of same only, but the temperature will be very high in the plasma arc welding. That we will see later. So this is up to the straight polarity. Now move on to reverse polarity. So whatever happening in the straight polarity, reverse will be opposite. So this is your DC supply. Now your electrode will be positive and your workpiece will be negative. So 70% of heat generation will be happen at electrode and 30% of heat generation will be at workpiece. So this is also called as direct current electrode positive or direct current workpiece negative. So one thing that you should remember, that in straight polarity your workpiece will positive. So you can remember easily for reverse polarity and straight polarity. So what's happening here? Now the most of the heat generation will be at electrode. So there will be less heat generation at the workpiece. So what will be the uses for this? You can use reverse polarity to join the thin sheets. Okay. So what kind of welding we are using? We will use in metal inert gas, MIG, TIG, and SAW. These all are types of arc welding only. We will see. One more thing that we should know. Now come to AC. Suppose, okay, I need one more slide. Now come to the AC. So what happens in AC? This also your current will be alternating, right? Positive, negative, positive, negative. So suppose this is your electrode, this is your workpiece. Okay, they are connected. So what will happen here? For at some time it will be positive and then it will be negative. Then again it will be negative and this will be positive. Then this will be positive and this will be negative because there is a alternating current. We are supplying alternating current. So most of the few time when it will be when your electrode will be positive, workpiece will be negative. Then workpiece will be positive, electrode will be negative. So what will happen here? Here it will be equally, your heat distribution will be equal for both electrode and your workpiece. Heat distribution will be equal for both. So now with the help of heat distribution, we can tell what will be the penetration depth for all type of power source. So suppose straight polarity. So in the straight polarity, your workpiece will be having higher heat generation. So there will be higher depth of penetration in the straight polarity. In the reverse polarity, less heat generation will be at your workpiece. So depth of penetration will be less in the reverse polarity, and in the AC it will be at medium, at center depth of the penetration, because equal heat will be generated at electrode and the workpiece. So this is
Ma'am, depth of
yes
penetration of what?
of your filler material if you are using.
Okay.
Okay, arc welding also. Okay, this is up to we have seen the principle for the arc welding. Now let's see about the arc blow. So arc blow, what is arc blow? Arc blow is a kind of a defect we can say. So it will degrade the quality of your weld. So what is arc blow? So suppose there will be a current flow in your workpiece, right? So when if a conductor and there is a conductor, and if you're flowing current into that, then there will be one magnetic field will be generated, right? So there is one magnetic field generated in your workpiece. Now suppose you are using a filler material. Okay, when you are using a filler material, when you are using a filler material, whatever the direction of this magnetic field, we can get by the use of thumb rule, right? So when your filler material, when you are melting your filler material, there will be a deflection of that arc towards the workpiece at the beginning and at the end of the workpiece because of the magnetic flux. Why? So suppose it is okay. One more thing that you should know, that the filler material that is deposited on your workpiece, it is less effect of gravity and more effect of magnetic flux, right? It is not mainly because of gravity it is deposited on your workpiece. It is because of the magnetic field that is present on your uh, workpiece. Okay, so at the corner of your workpiece, your magnetic flux lines will be changing their direction, right? At the end, both of the ends, your magnetic flux line will be changing the direction. So because of that, suppose if you have started your welding from here, so if here the direction will have changed. So that is why whatever the our electric arc that was depositing on your workpiece, that will start deflecting towards the inner of a workpiece, and same for the ending, because here your magnetic flux line will change the direction. it will again start attracting towards the workpiece. So there will be the deflection of your arc due to the magnetic flux line. So this deflection is called as arc blow. So that is why at the end and at the end, beginning and end of your workpiece, your weld, there will be no weld. I hope you understood what I'm trying to say. So this is called as arc blow. So what we do to what we do to eliminate the arc blow, we provide some extra material at the end and at the beginning of the workpiece. So those are called as uh, to reduce the welds better. And one more thing that we can do, we provide a flux coating on your arc or electrode. What is that flux coating? Flux can be made of any oxide materials or ceramic. We provide a coating. So what happens? This coating, your firstly your electrode will start melting, and your coating will be present. So your coating will help to help the ignore the magnetic flux effect on your electric arc. So with the help of coating, it will be still present and it will eliminate the effect of your magnetic flux line at the beginning and at the end. So there are two ways to ignore the arc blow. One is provide some extra workpiece material at the beginning and at the end. And second, you can use flux coating. So flux is very important that we will see in the next slide. Let's see what is these are the remedies for the to ignore the arc blow. First, that we have seen, provide some extra material at the beginning and end of the workpiece. That is called as tab in and tab out. Then you reduce the intensity of current. That all you can decide. And then provide the flux coating at the electrode. Now see what is flux and what is the function of the flux. So
Madam,
flux is the coating that we provide on the electrode material. So flux coating will be act as a deoxidizer. Suppose this is first of all, this is a molten metal that will be deposited on your workpiece. So there are high chances of forming oxidize. So if
excuse
oxidize,
me, madam.
if oxidize oxide
Madam,
will, yes
can you
please.
explain that how flux coating reduces arc blow once, please?
See, this is your suppose this is your electrode and you are providing some coating on that. So firstly, if you're trying to reduce the arc blow, you will add coating of some material, so that firstly your only electrode will start melting and this will be present. So after that this will be more than your arc. So with the help of heat, it will start melting, but the shield of your flux material will protect it from the magnetic flux line. So this will be not a conductive material. So inside it will start melting, but it will not be able to attract this electric electrode material due to the magnetic flux line. So it will automatically deposited on the place that you want it to be built.
Means magnetic lines effect is reduced by flux coating.
Flux coating, yes.
Okay.
Ma'am, galvanic spatter means no
Sputter means,
deposition,
see,
no deposition at the end of the workpiece.
no. Sputter means what? See, if you're firstly, when it will start melting, it will be deposited like a drop way. But with if magnetic flux lines effect will be there, so your these drops will start deflecting and it will start depositing on the other parts of your workpiece. So you might have seen during welding there will be some droplets of the electrode or your filler material present on your workpiece, not at the welded joint. It will
Yes,
also,
ma'am.
that is
Yes,
called as sputting. That is a defect of welding.
Ma'am, what do you written on A and B? Or is it the different position?
Yeah, this is the end position, then B is the, this is the beginning, this is the end.
Okay.
Okay, now we will see the function of flux coating.
Ma'am, the direction is changing at the initial position, end position.
I'm sorry, direction what?
Uh, I mean, there is a the filler material is getting attracted to it, isn't it? You had drawn the.
Yeah, that's what I'm see. Why here it is attracting and here it is attracting here? Because see, here it will change the direction, right? Here it will change the direction, and here it is attracting because of the magnetic flux line. Here the flux line will change, here the flux line will change the direction. Now that is why it will not attract at this moment. So from where it will be get attracted towards this side only, right?
Yes, ma'am.
So here also it will change the direction, here also it will change the direction. So it will get attracted towards the workpiece. Okay.
Okay.
Now let's see the functions of flux coating, which is important. Apart from reducing the arc blow, what other function that flux coating does? That first is it works as a deoxidizer. So what it will do, what flux will do, suppose your molten metal will be there, so it will start forming oxide in the atmosphere. So suppose a metal is there, molten metal is there, it will react with the oxygen and oxidation will happen. So these oxide will degrade the property of your weld, right? This will degrade the property of your material. So what your flux will do? Flux will, now we will use that kind of flux that will also start melting with the electrode material. So this flux will react with the oxide, with the oxygen, and it will start making a slag. This material is called slag. So there will be a coating of slag which will be of very low density form on the above of your weld pool. So that is how your slag will control the heat transfer rate of the liquid metal, and there will be no oxide form because your flux will react with the oxygen and form a slag material. So this will also increase the strength of your joint. The slag will also increase the strength of your joint. So these are two functions that are for flux. First is it will work as a deoxidizer, and then it will also reduce the effect of magnetic flux line, hence there will be less arc movement. Now, now arc welding is divided into two categories. One is consumable electrodes and second is non-consumable electrode. So what is happening here? What we use our electrode to produce arc, right? Arc is what? In simple terms, we can say arc is heat. So we are producing with the help of electrode. So in the consumable electrode, your electrode will work as a filler material. Okay, it will be deposited on your workpiece. But in the non-consumable electrode, if there is a need of filler material, that is, if it is less than 5 mm, then there is no need of filler material. Then you don't have to use filler material. If the distance is greater than 5 mm, then you have to use a filler material. And in this kind of non-consumable electrode thing, you have to use one filler material also if it is needed. In the consumable electrode, your electrode will be work as a filler material and it will get consumed during the welding process. So there are six types of arc welding, which there is a consumable electrode, and two types in which there is a non-consumable electrode. So there are direct questions in your exam that they will ask, then which kind of welding is have consumable electrode and which kind of welding is have non-consumable electrode. So the welding that you should know first was MIG, that you should know what it is. So you should know these all are important that we will see in the detail. TIG and this kind of 4 welding process that you should know. Other welding process is similar only. So let's see a brief about these welding processes. Let's start with the consumable electrode. So first is MIG, that is metal inert gas or metal active gas welding. So this is also called as gas metal arc welding. Here what we will do, we will use one inert gas atmosphere so that there will no oxidation, and the same with the help of arc welding we will join the sheets or whatever the welding, wherever the welding is required. Next is shielded metal arc welding. So this is also called as stick welding or manual metal arc welding. So here what will happen, the welded metal will be protected from the atmosphere by a shielding gases and slag will be produced. So in the shielded metal arc welding, one electrode will have some flux coating. Due to that there will be one slag formation, and which will help to protect it from the atmosphere. The third type is flux cored arc welding. So in this what will happen, your flux material, uh, you will choose your flux material so that while melting it will it will itself generate some gas, it will itself form some gas, and that gas will help as a shield for the atmosphere. So in this what we are using, we are making slag to protect our weld pool from the atmosphere. In this what will happen, your flux will generate or form gases. So therefore you don't need to provide any other protection. Here what we are doing, we are having inert gas atmosphere. So the working for all these three will be same only. What we are doing, just we are changing the protection way. Next
No
is
slag, no slag formed in the flux coated flux cored arc welding.
what we are doing, some material we are changing, we are choosing so that some gas will form uh, when your flux will be melted. So it is possible that your flux is just vaporizing, right? So there will be no slag in this kind of. Okay. Now next three is, first is submerged arc welding.
Ma'am, that gases formed wouldn't it react with the metal?
It will not react with the metal, I guess.
We are using inert gas for the
See,
big.
inert gas also sometimes we use in nitrogen atmosphere also we use. So there are few gases which don't react with the molten metal, like nitrogen and SF6. So these kind of we will use such gases. Such gases will form that will not react with your molten metal.
हम आर्गन CO2 रिएक्ट करती है.
Argon.
हाँ, आर्गन एंड CO2.
CO2 and argon will not react for sure. CO2 could be used also. Depends
मैम
upon it will depend
Temperature.
upon what material you are going to prepare.
मैम
Depend upon temperature also, no, ma'am?
Yeah, temperature
So,
also.
मैम इनर्ट गैस को एक्टिव गैस के बोल दिया है तो थोड़ा उल्टा नहीं लग रहा.
किधर बोला है मैंने?
मेटल इनर्ट गैस और मेटल एक्टिव गैस एक ही चीज है.
Metal active gas welding, that is name only. It is not that they are saying that your inert gas is active gas. It may be they are referring this active word for metal, not for the gas.
Okay.
Okay, this is I have seen. I think this is some they're using like this is USA terminology and this is British terminology like that. I have seen. That is why they're using two different names. MIG you should remember always.
Okay.
Then the next three types are submerged arc welding, electroslag welding, and arc stud welding. So these three mostly no one knows also, but these all also the arc welding type. Submerged arc welding you might have seen. So what happens? It creates an arc between the electrode and the workpiece, and that arc will create a cover of fusible flux, which creates a gas shielding around the metal to save it from corrosion. It's some kind of whatever we have seen as previous. So this we will see in later detail, like with the diagram, submerged arc welding, then arc stud welding and slag welding. That you should know little theory. Like arc stud welding is what we are doing here. We are joining the metal pieces with the stud component. Suppose there is some nut or bolt. So just to weld with the help of that, we are using arc stud welding. Then the electro slab, there will be a molten slab that is created by the heat of electrical supply to cover the weld surface. So it all kind of six metal arc welding which are using consumable electrodes. The working of them almost are same. So you should know by the name, and few we will see later on. Now let's move on to based on the non-consumable electrodes. There are two types: tungsten inert gas welding and plasma arc welding. So in tungsten inert gas welding, as the name says, we will use one tungsten electrode, and in this type, uh, okay, and in plasma, what we will have with the help of a ceramic nozzle, we will provide high velocity plasma at high temperature. So you will comfortable with this whole plasma, right? So in that these two working also we will see about TIG and PAW. That is very important. TIG is very important. Most of the time they ask numerical from this. Then let's move on to welding technique. So according to the on the basis of the movement of the electrode, it is divided as linear welding and uh, constant arc welding. So suppose if there is a linear movement of electrode with respect to workpiece, it will be known as linear welding. And if there is a downward movement of electrode, then it is called as downward welding. So these are two welding techniques. Then the power which is generated, the formula you should know, P is equals to VI, and whatever the arc voltage that is generated is dependent upon the arc length. Okay, whatever the arc voltage that is produced, it has a linear relationship with the arc length. That this also you should remember. This is also very important. Now uh, there are two types of welding machine. First is, okay, why do we need a different type of welding machine? So suppose you should know. Suppose you have provided very high current. Okay, very high current, or you have provided very low current. So while you're doing while you're doing the welding process, your electrode got stuck on your workpiece if you're not providing the uh, effective amount of current or voltage. So that is why there are two types of welding machine. One is constant current type and second is constant voltage type. So what is constant current type? For a small change in arc voltage, the corresponding change in current will be very small. These are used in the manual arc welding technique. So what is it saying? This is the VI characteristic. So in the constant current type machine, your VR characteristic will be like this. This is what called as droop type. So what is it saying? So suppose this is your V1, this is your V2. Okay, so there is a change in your voltage from V1 to V2. There is a change, but as compared to that, there is a small change in your current. So there is very small change in your current. It will be more steeper than what I have made. So there will be a very small change in your current. So that is why we can call it as constant current type. So when will it use? So this was your electrode. This is your workpiece, and this will be your arc length. Okay, arc length. So when you are moving, you will manually you are moving your electrode while welding. So there are possibilities that with you are doing it manually, right? So there are possibilities that your arc length is changing continuously, and we have seen that our arc length has linear relationship. Let's write it as VA. Arc length has linear relationship with your voltage, right? So if your arc length is changing continuously, your voltage will also be changing continuously. So your current should not change because your current will be deciding what amount of heat will be generated, right? Your current will be decided. So if your current is also changing continuously, so there will non-uniform heat generation. If non-uniform heat generation will be there, your weld quality will not be good. So what is desired here? Constant current if you are doing manually. So when you are doing manually, this kind of constant current type machine will used when you're doing it manually. So that even if there is a small change, if there is a large change in your voltage, your current will still constant because we consider it constant because the change in current is very less. Now next type is constant voltage type. Here now your curve will be like that. So in this, for a small change in arc voltage, the corresponding change in current will be large. So this will be used in automatic welding technique. So here, what will happen? You will be doing your welding manually. So your arc length will not change, and that's how your voltage will also not change. So you will provide a your current will also not change. So when you are doing when there is a automatic welding process is happening, then you can use constant voltage type of machine. But when there is a you're doing it manually, there are lots of joining processes where you will not be able to use a machine. You have to do joining or welding manually. So then you will use constant current type. So this kind of question also they can ask. Suppose you're manually joining something. So what kind of welding machine will be used? So your answer will be constant current type. Okay. Any doubt still now?
Ma'am, why we are maintaining constant voltage in constant voltage type?
See, if there is a change in the voltage, there will be change in your current, right? Because of that current only heat is produced, right? So if your current is varying, the heat generation at your workpiece will vary. Suppose you are joining like that. This is your two sheet. Okay. Here more heat was there, here less heat was there. So there will be difference between this point and this point. There will be difference in properties of your well in this point and this point, right? What you want
Got
your
it.
heat generation, your heat constant, uniformly. So that is why you should maintain constant current. Okay. Okay.
Okay, ma'am.
So now a few terminologies, electrical base that you should know. First is open circuit voltage. When there is no load, that is your circuit is open. Your electrode, one more thing that I can tell you, that there is your electrode, and this is your workpiece, and there is a huge amount of gas. So there is no current flowing between them. There is a huge amount of gap is that. So whatever voltage will be there, that will be called as open circuit voltage. So it is the maximum rated voltage that can be measured between two open terminal under no loading condition. So when your workpiece and electrode are far away, then that is why there is no current flowing, then that voltage will be called as V naught. Then short circuit current, what we are doing, we are producing arc with the help of short circuit, right? Now what we will do, we will reduce the distance between the electrode and workpiece, and there will one arc will form. So at what current it is forming, that will be called as short circuit current. So it is also called as maximum rated current, which is required to generate the arc. At this current, uh, short circuit current, your arc will generate it. Okay. So these two things. One more thing is duty cycle. What is duty cycle? It is also a term. It is the percentage of time during which arc will be on without overheating element in a welding machine. In the terms of the formula, what is duty cycle? Arc time divided by arc time plus idle time. That means when the arc is, suppose here at open circuit voltage at no load condition, there will be no arc, right? But at short, whenever the short circuit will be there, arc will be generated. So your duty cycle will be decide the effectiveness of your welding process. So through the time there will be arc, that will be called as arc time, and the other time where there is no load will be called as idle time. So mostly in the AWS and BIS, we try to maintain at least 60% of duty cycle. So that 60% of time your arc will be present and there is no idle time. So this is one more term as duty cycle. Okay, now this is your VI characteristic.
Can you explain once again what is duty cycle?
Sorry?
Duty cycle.
Yes, duty cycle is a term. So this is a percentage of time during which arc will be on without overheating element in a welding machine. So it will tell you at which time there was arc present and welding was happening. This time your welding process will be happening, and the idle time there will be no welding. That is what duty cycle will tell you, the effectiveness of your process.
Okay.
Madam, can you go back to previous slide? Yes, ma'am.
Yes.
Here, short circuit current corresponds to requirement to generate arc or maximum current.
See, this is called as maximum rated current. Your short circuit current that I told you, when you will reduce the distance at some length, at some distance, there will be one arc generated. That we have seen how arc is generated. So that current that will be flowing, that will be the maximum rated current. Okay, let's see with the help of the graph. This is the VI characteristic of your arc, right? This will be your short circuit current. This will be your open circuit voltage. Okay, so when you are reducing your arc length, that means you are reducing the voltage, right? Because your arc voltage is having linear relationship with your arc length, right? So suppose you're coming closer. That means you're reducing the voltage. Okay, so as the voltage will be reduced, your current will be increasing, right? Hello, it is increasing. So at some current there will be arc will be generated here.
Yes, ma'am.
So that current is called as short circuit current. That is why here written as maximum rated current.
Okay, ma'am.
Okay. Okay. So it is here they are just written the equation of this straight line. So suppose there is a straight line like this. There is a point x and y. So what is the equation of this line? It will be this. This is your a, this is your b. This will be the equation. X by a plus y by b is equals to 1. So similarly, they have written it and vt is some point here. it and vt. Is is what? Your short circuit current, and V naught is what? Your open voltage, open circuit voltage. This is your short circuit current. So this is one relationship that you should remember by heart, and this is one relationship that they will give you in question also. But these two relationships are very important to solve the numericals for arc welding that you should remember. Then in the stable arc generation conditions for both constant current type and constant voltage type, that mostly we have seen. Rest we have theory you seen the notes. Now this is also very important formulas. Okay, now this is mostly whatever the till now this was the general for arc welding. Now these formulas are mostly for your TIG kind of, where you're using a filler material. So what is happening here? This is what kind of joint? Can anyone tell?
Butt joint.
Butt joint.
But
Suppose this is a butt joint. Okay, and we can write the area for it, right? This is your width D, and this is your thickness T. So this is your area. So there are few terms. Your power will be V into I, the power, and small v is equals to v is what? Your feed rate or your welding rate. So there are few terms, that is heat transfer efficiency, heat required to melt, and heat supplied. So what are those? So for what is happening here, so there will be one heat generation. Okay, that is your heat generated. Then there is that heat will be supplied to your material. Okay, your workpiece that should be melted. And there is one heat which is required to be melted. So there are possibilities, not whatever the whole amount of heat which is generated, not all the heat will be supplied, right? Not all the heat will be supplied. Supplied. So there is one thing that is called as heat transfer efficiency. It will tell you how much heat is supplied after the generation. Suppose some amount of heat is generated and some amount heat will be supplied. Not all will be supplied. So your heat transfer efficiency, that will depend on your heat transfer efficiency. So with that, this is your heat transfer. Next is HM and HS. So heat of melting we all know. This is the amount which is required to melt a metal, mc del T plus the latent heat term, right? Then the heat supplied, whatever the heat supplied will be H generated into the efficiency, right? This will be your heat supply. So what is your generated? That we can calculate, right? That we can calculate because we know the voltage, we know the current that we are supplying, we know the area, we know the velocity. So we can calculate the heat, whatever the generated. So whatever the heat terms that will be using in here will be per unit volume. So your Hg is whatever the heat is generated is V into I, that is power, divided by area multiplied by the velocity. So this is your Hg. So with the help of that, there is one formula formed for the actual amount of heat transfer on workpiece. That is Hs is equals to Vi divided by Ab into V multiplied by heat transfer efficiency. Okay, you are getting what I'm trying to say? Then melting efficiency. So whatever heat is supplied, uh, the full will not be utilized for the melting, right? There will be some loss. So that will be represented by the melting efficiency. So now your melting efficiency will be heat melted divided by heat supplied. So heat supplied, we got this formula. So in the questions, what kind of question they will ask? They will give you melting efficiency and heat transfer efficiency, and they will give you few more terms, and they will mostly ask you heat supplied or heat melted, or they will ask you the feed rate or velocity, welding power. So you should know what is happening here. Your whatever the generated heat that will be supplied, there will be one transfer, heat transfer efficiency. Then the supplied will be utilized to melt the metal. So there will be one melting efficiency. So and also you should know these formula for power. So this is a way to remember this. Now we will see what kind of question they will ask. So any doubt in this? I told you the way to remember this formula so that you should not get confused in that. Any doubt in this?
Ma'am,
Yes.
H equal to I square RT, the heat generated.
Yes.
Okay.
Correct. That is in the term of resistance. We are not using that term.
In
We are
resistance,
converting it into this form. P is equals to power time.
H equal to I square RT in the resistance welding only.
Sorry. H is equals to I square RT. With the help of that formula only, this formula is derived. Okay.
B equal to IR, so therefore it's I square R from 1
Yes.
I.
Okay. Any doubt? Okay. Now try to solve this question.
Ma'am, one thing on that equation, ma'am, what, where is the T? It should be VIT, na? In that.
Where?
HA equal to VI by AR into V.
H. This one.
Last equation.
This one.
Uh-huh.
Okay. H. This will be H.
Velocity, ma'am. This is a velocity, na? Second cancel. AB into V.
This one, what I have written is wrong, na?
I think, ma'am, right.
I have written right only.
Okay.
This is Hg, not Hs. Okay.
Okay.
Hg will be this term. Okay, now try to solve this question.
Madam, what was that? What was
Your voice is breaking. Can you say it again?
what was that trick to remember flow of heat?
Again, it is breaking. Can anyone else tell what he's trying to say?
How to remember the formula?
How to remember the formula? Okay. See, first.
Not formula, man.
Okay. Process. What is happening?
That the HG, HS, and HM. Yes.
There will be one heat generated. Okay. Because of the arc, heat will be generated, right? So not all the heat will be supplied. So that will be decided by the heat transfer efficiency. Okay. your heat transfer efficiency will be there, that is Hs divided by Hg. Then whatever the supplied heat will, not all the heat will be utilized in the melting. There will be some losses, so that will be represented by melting efficiency. That's what I was telling. Then the generated you can calculate because you know the voltage and the current and the V that you are using in the area you are using. So Hg you can easily calculate. So if you can calculate the Hg and they have given you the efficiency, you can calculate the supplied. And if they are giving the melting efficiency also, you can calculate with the help of that whatever the required amount of heat to melt. Otherwise, if they are giving other data in the question, then with the help of that also they can calculate. Suppose they will give you only HM, then they will ask you HG and they will give you all the efficiencies. Then also you will be able to calculate this way. That's what I'm trying to say. Either they will ask you to go this way or they will ask you to go this way. This kind of question they can ask. Now a few questions at least we will try to solve in this session.
मैम
Yes,
एचएम का यूनिट क्या है? व्हाट इज यूनिट ऑफ एचएम? जूल और जूल पर मीटर यूनिट को
per volume, per annum. Unit you said
by the
unit
formula.
whatever they have
Ma'am, by the formula it seems to be joule. By the formula
yeah, but
HM
when
is
you'll be using you'll use per unit volume.
okay.
Okay, now try to solve the question. Should I solve this question? Next you will try.
1 minute.
For 20,
4?
25.
Yeah, correct. Okay, let's see this question. The VI characteristic of a direct current arc in an arc welding process is this, where L is the length of the arc in mm and V is arc voltage in volts. During a welding operation, the arc length varies between 1 and 2 mm and the welding current is in the range of 200 to 250 ampere. Assuming a linear power source, the short circuit current. They are asking you short circuit current. So one formula that we have seen, V open circuit, V divided by V open circuit plus I divided by I short circuit is equals to 1. This is the one formula that we have seen for VI characteristic. So what they are asking you I short circuit. So okay. So firstly, they have given you a range that is minimum and maximum for both arc length and the welding current. So this is your VI characteristic, right? Okay. So one thing we can see, if your arc length is 1, so what will be your welding current?
140 volts.
Welding current.
Yes, ma'am.
250 we will choose, right? For the minimum, when you will
Yes, ma'am.
take minimum arc length, that will give you minimum voltage. That will give you the maximum range of current, right? So that we know. So firstly, we will calculate our V1 for first condition when your arc length is 1 mm. So it will be 100 into 100 plus 40 into 1. So your V1 will be 140. At this, your I1 will be 250 ampere. So one equation will form from here, that is V 140 divided by V0 plus 250 divided by I short circuit is equals to 1. This is your equation 1. Second is what? When your arc length is 2 mm, what will be your welding current? That will be 200. So your V2 is 100 plus 40 divided by 2, that will be 180. And at this, your current is what? I2 is 200 ampere. So now we will be able to form our second equation, 180 divided by V0 plus 200 divided by I short circuit is equals to 1, equation 2. So now we have two unknowns in two equations. So we can easily solve these two equations. And when you will solve this equation, your I short circuit will come as 425. Okay, any doubt in this? Now you can easily solve these two equations, right? You want me to solve them? From here you calculate V0 and then you put the value of V0. From here V0 will be 1 minus 250 ISC multiplied by 1 upon 140. So this value we will put in this and you can usually get the I short circuit. Any doubt in this question?
It is constant current or constant voltage method. Type of welding machine.
Yeah, if you write it like that also. Why I use this diagram just to tell you that when you are using the lower voltage, then you have to use the maximum current. Okay, this is my mistake. You can use I was just referring this diagram to tell you that we'll use this also. The same thing will go, right?
Okay.
Okay. Okay. Now try to solve this question.
For same power supply,
Sorry.
If you reduce voltage, then current will increase now. So this logic is applicable over there.
Okay, right. Now try to solve this question.
Is it 25?
Let me check. Yeah, it is 25 kVA. Correct. So, in this question, what is it asking? It is similar kind of question. Let me let's solve this. In a direct arc welding process, the power source has an open circuit voltage. VO is 100 volt and short circuit current as 1000 ampere. Assume a linear relationship between voltage and current. The arc voltage varies with the arc length as 10 plus 5L, where V is in volts, L is in mm. The maximum available arc power. So power we know will be VI, right? So for V we have one equation. For I we need to get one equation. So again the same V upon V naught plus I upon I short circuit is equals to 1. Now you'll put the values plus I divided by 1000 is equals to 1. So from here you will get I is equals to 1000 minus 10, 10 plus 5L. So I will be 900 minus 50L. So I also we have calculated in terms of L. Now you can write P is equals to 10 plus 5L and 900 minus 50L. So we need maximum available arc power. So for that we will differentiate it with respect to L. This will be 500 minus 50L plus minus 50 into 10 plus 5. When you will solve this, 5 minus 50L, this will be 100 and your L will be 8, right? Will be 8 mm. From here you will calculate that for L is equals to 8 mm, you will get the maximum power. Now what we will do, we will fill this value in this equation and it will come around 25, right? 2500 voltage ampere, then it will be 25.00 kilo voltage ampere. Any doubt on this question?